Well, hello again. I'm going to go over the relationship between the acid dissociation constant, the base hydrolysis constant, and the auto ionization constant for water, Ka, Kb, and Kw. Specifically as it has to do with diprotic and polyprotic acids. I'll start with a monoprotic acid. We have our generic acid HA that dissociates into a proton, or more properly hydronium, but we'll leave that, and the anion with its dissociation constant Ka. If we then take the conjugate base, the anion, add water, and it protonates to form the acid and releases a hydroxyl with its hydrolysis constant Kb, or some people call it dissociation constant. If we add those two reactions, the acid and the anion drop out, and we end up with the autoionization of waters. Ka times Kb is Kw. It's a little bit different with diprotic acids. Let me erase this to give myself a little more room. And so let's look at a diprotic. And we could use, I don't know, maleic acid, or we could use carbonic acid, or we could use succinic acid. I'm just going to stick with the good old generic H2A. We've got two dissociable protons, and we release a proton and have our intermediate species HA minus, so that's Ka1, and then that can go on. This is going to be a weaker acid almost always, perhaps always. That can go on and dissociate, release a proton, and give us our A2 minus. That's Ka2. All right, so HA minus, whoops, that's 2 minus there. HA minus is the conjugate base of H2A, our diprotic acid, and A2 minus is the conjugate base of our intermediate form, HA minus. So let me, so here's where it gets a little bit different, in that this A2 minus is a dibasic or diprotic base, so it is a stronger base than HA minus. So if I were to, let's start with the top one here, and no, let's start with the A2 minus. So that'll give us our intermediate form back and a hydroxyl. Now that is Kb1. That is a stronger base. And then this HA minus, once again, can hydrolyze. And that'll give us back our original acid. And that is Kb2. So if you look at this, let's tell you what, let me erase this one. And line up Kb2 here. So we've got HA minus plus water gives us our H2A and a hydroxyl back, and this is KB2. All right, so if we add those together, I'm going to have to erase this again to get rid of it. So we add these together, and my HA minuses go away, my H2As go away, and we get our water dissociating into a proton and a hydroxyl. So the stronger acid and the weaker base go together. So we've got Ka1, Kb2 is Kw. And we also have Ka2 times Kb1, the weaker acid and stronger base, also Kw. So it's a little bit tricky until you think it through. So we've got our stronger acid going up in this direction, and we've got our stronger bases going down in this direction. So the stronger acid and weaker base go together to make our Kw, and the weaker acid and the stronger base go together. Actually, that isn't quite what I wanted to say, but I hope you get the point. So the stronger acid and the weaker base go together. And if you have a triprotic acid, it'll be the strongest acid and the weakest base, the intermediate acid and the intermediate base, and the weakest acid and strongest base. So the basic idea is the same here. And so I think that's all we need to know for now. So I will see you again when I have something else to show you.